Welcome to this EWRB Electrical Service Technician Training course. I'm Aria, an electrical tutor working with Whitroy. In this course, I'll guide you through all the topics covered in the EWRB Electrical Service Technician Exam Teaching Guidelines. Welcome back. In our previous lesson, we explored testing and measuring instruments, learning how to use meters and insulation testers safely. Now we'll take that knowledge into a real, hands-on application, testing electrical appliances. This is topic 8.18, Electrical Appliance Testing. Every service technician must know how to inspect, test, and tag appliances correctly, following is /NZS 3760, the New Zealand standard for in-service safety inspection and testing of electrical equipment. Let's begin with Topic A. Topic A, Purpose of Appliance Testing. The purpose of appliance testing is to make sure that any portable or plug-in electrical equipment remains safe to use throughout its service life. Even the best designed appliances can become dangerous over time because of damage, moisture, or wear. Testing checks the integrity of the insulation, the continuity of the earth, and the correct polarity, ensuring the equipment won't give anyone an electric shock or start a fire. Under S/NZS 3760 and Regulation 15 of the Electricity, Safety, Regulations 2010, testing is part of maintaining safe workplaces and public environments. Topic B, Classes of Appliances. Now let's move to Topic B, Classes of Appliances. All appliances fall into two main classes, Class I and Class II. Let's speak that clearly. Class I appliances are earthed appliances. They have a metal body connected to the earth pin in the plug. If a fault makes the metal live, current will flow safely to earth and trip the protective device. Examples include kettles, toasters, washing machines, and irons. Class II appliances are double insulated. They don't rely on an earth for protection, instead, they have two layers of insulation or reinforced insulation around all live parts. You can recognize them by the double square symbol on the rating plate. Examples include drills, hairdryers, and phone chargers. So, in spoken summary, Class I uses an earth for protection. Class II uses insulation for protection. Topic C, Visual Inspection. Now let's move to Topic C, Visual Inspection. Visual inspection is the first and most important step, because most faults are found just by looking. Before testing, check the plug top, no cracks, burns, or loose pins. The flexible cord, no cuts, abrasions, or exposed wires. The appliance body, no damage or missing covers. The rating label must be legible and secure. That the cord grip is holding the outer sheath firmly. If the appliance fails a visual inspection, do not proceed to testing. Label it out of service and report it for repair. According to AS/NZS 3760 Clause 2.3, visual inspection is required before every electrical test. Topic D, Earth Continuity Test. For Class I appliances. Now for Topic D, Earth Continuity Test. This test ensures that the metal frame or body of a Class I appliance is effectively connected to the earth pin of the plug. Here's how to perform it in spoken form. 1. Set your portable appliance tester or continuity meter to the low ohm range. 2. Connect one lead to the earth pin on the plug and the other to the metal body of the appliance. 3. The test current should be at least 200 milliamps. The result must be less than 1 ohm to pass. If the reading is higher than 1 ohm, check for loose terminals or corroded earth points. Failing this test means the appliance could live in a fault situation, so it must not be used. Topic E, Insulation Resistance Test. Now let's move to Topic E, Insulation Resistance Test. This test checks the integrity of the insulation between live conductors and exposed metal parts. Here's how to describe it. 1. Set the insulation tester to 500 volts DC. 2. Connect one lead to the active and neutral conductors, joined together, and the other to the earth conductor or appliance frame. 3. Press test. For portable appliances, the minimum acceptable reading is 1 megohm. New appliances should show well above 10 megohms. If the reading is below 1 megohm, the insulation is degraded, possibly from moisture, dirt, or heat damage, and the appliance must fail. Always make sure the appliance switch is turned on during this test so that the internal circuits are included. Topic F. Polarity and function test. Now for Topic F. Polarity and function test. Polarity testing ensures that the active, neutral, and earth conductors are connected to the correct pins on the plug and socket. This is especially important for extension leads and detachable cords. A polarity tester checks that active connects to the right-hand slot of the socket, neutral to the left-hand slot, and earth to the top pin. If polarity is reversed, the appliance may appear to work but remain dangerous. For example, the metal body could stay live even when switched off. Always check polarity before returning an appliance to service. Topic G. Testing leads in portable RCDs. Now let's move to Topic G. Testing leads in portable RCDs. Flexible cords, extension leads, and portable RCDs must also be tested under AS/NZS 3760 Clause 2.4. For leads, perform a visual inspection for cuts or twisting. Conduct an earth continuity test. For Class I leads, perform insulation resistance and polarity tests end-to-end. For portable RCDs, press the test button. It must trip immediately. Reset the RCD and test again with an RCD tester. The trip current must be no more than 30 mA, and the trip time no more than 300 milliseconds at rated current. Leads in RCDs are safety devices themselves, so never return one to service if it fails any test. Topic H. Tagging and record keeping. Now for Topic H. Tagging and record keeping. Once an appliance passes all tests, it must be tagged to show the result and the next due test date. Each tag should include the tester's name or company, the test date, the next test date, and whether the appliance passed or failed. Tag colors often follow a site or industry schedule, for example, quarterly colors on construction sites, but the key point is that the tag must be durable and legible. If the appliance fails, attach a clear failed. Do not use tag and remove it from service immediately. All results must be recorded, either in a logbook or digital system, as required by AS/NZS 3760 Clause 2.5. Now let's move to Topic G. Testing leads in portable RCDs. Applied example, testing a Class I and Class II appliance. Let's look at a practical example. You're testing a kettle, Class I, and a drill, Class II. For the kettle, you first perform a visual inspection. The plug is sound, cord intact. Next, you carry out an earth continuity test, 0.12 ohms, pass. Then you test insulation resistance between joined active neutral and earth, 12 megohms, pass. You tag it tested, safe to use, with the next test due in 12 months. For the drill, it's Class II, so no earth test is required. You inspect the double square symbol, check insulation, and test between active and neutral to the outer casing. The reading is greater than 200 megohms, pass. You tag it accordingly. Both appliances are now proven safe for continued use. Let's finish this part with a practical example. Bringing it all together, let's summarize Topic 8.18, Electrical Appliance Testing. We began with the purpose of testing, to keep portable equipment safe. We defined Class I and Class II appliances and their protection methods. We learned the key tests: visual inspection, earth continuity, insulation resistance, and polarity. We covered testing of flexible leads in portable RCDs, and how to tag and record the results correctly. Finally, we saw a real example of testing a Class I kettle and a Class II drill. Checklist summary. Here's a quick checklist to memorize. Inspect earth, test insulation, test polarity, tag record. Repeat it. Inspect, test the earth, check insulation, verify polarity, tag the result, and record everything. Summary. To wrap up, visual inspection is the first safety step. Earth continuity applies only to Class I appliances. Insulation resistance must be at least 1 megohm. Portable RCDs must trip within 300 milliseconds. Tag and record every test result. That concludes Topic 8.18, Electrical Appliance Testing. In our next lesson, we'll move on to Topic 8.19, Electric Motors, where we'll study motor construction, operation, and testing, and we'll split that topic into 2 lessons, since it's a long one.